All right, so let's take a look at two more kinds of financial applications. First, we're going to see how long it's going to take for an investment to double in value if it earns 6% compounded continuously, and how we also want to figure out how long for that investment would take to triple. So, a couple things. First, we need to figure out what formula we're going to use. Now, in the problem, it says how long will it take to triple if it's compounded continuously. That word tells us continuously. Tells us we're going to use A equals P E to the RT. That's the continuously compounding formula. So it says how long will it take for an investment. It doesn't give us a specific amount. So the P value we don't know. So P is unknown. And we don't really know A then if we don't know P, but we know it's supposed to be double whatever P is. So let's see here. What else do we know? We know that it's supposed to earn 6% interest, so your rate is 6%, which means in this problem we're going to use 0.06 for the rate. And the time, that's really what we don't know. That's what we're trying to figure out. So we're going to have to make some assumptions. And it's with the amount of money that we have initially. So just come up with an amount. So usually what I like to do is if I assume that I start with $1, and that's really the lowest. I think this is the easiest way. Or if you want to do something a little more out there, like use 100 or 1,000, whatever you want. I'll show you how to do it with a different value when we do the tripling one. So let's just say I start with $1. If I want to figure out how long it's going to take to double, then A is going to end up being $2. And so then we still now only have one true unknown, and it's what the time is. So if we take all of these values and plug them in, so we're going to figure out how long it's going to take to get $2. If we start with $1, E is our constant. Your rate is 0.06. And then time is the unknown. All right, so first things first, you're going to start by, well, we don't want anything in front of E, and technically there isn't, but if I just kind of show you, divide both sides by 1, so you get 2 is equal to E to the 0.06 times T. Now I've got to figure out how to get that variable out of the exponent. And this is where we're going to use natural logarithms. So on both sides, you can put ln 2 is equal to ln of e raised to the 0.06 t. With the introduction of those logarithms, this is how we're allowed to take this exponent and move it out front. So once you move that exponent out front, give myself some more space over here. All right, when you move that exponent out front, what you're going to end up with is ln of 2 on the left side is equal to 0.06t times ln of e on the right. Now we know that ln of e is equal to 1, so this is really nice. We don't even have to worry about this because really it's just times it by 1, so we can kind of ignore that. And if we're trying to get t by itself, all we have to do now is divide both sides by 0.06. So time ends up being 11.55 years. Okay, and you can always go back and double check. You could always take 11.55 and plug it in for t here and make sure that you actually get 2 on the other side. Just keep in mind 11.55 is rounded, so it's an approximate value. So you might not get exactly 2 when you type it back in, but it should be really, really close. Let's take a look at how to triple. So if we want to figure out how long it's going to take to triple the investment, we're still going to use A equals P times E to the RT, because it's still compounding continuously. But let's use something different. So let's say I start with, I don't know, $1,000. If I want $1,000 to triple, that means that our A value is going to end up having to be $3,000. The rate is still 6%, so it's still 0.06, and time is still our unknown. So when you plug everything in, you have a 3,000 on the left, 1,000 e to the rate 0.06 times t. Now here's where you'll see why I like to use $1 and $2 versus picking some other values. You have, before you can put ln's on both sides, you have to get e and its exponent by itself, which means the first step you're going to have to do is you're going to have to start by dividing both sides by 1,000. And to be completely honest, this is one of those steps that a lot of people They just get so eager to get that t out of the exponent that sometimes they overlook that, and that's a huge mistake. So be really careful. So we end up with 3 on the left side is equal to e to the 0.06t on the right side. And had we used $1 and $3 initially, this really would be what we started with. But it's personal preference. You can do what you like. I just want to caution you, if you use something like 1,000 and 3,000, just make sure you divide away that number first before you start to use ln's. So now we can put the ln's in. ln of 3 is equal to ln of e to the 0.06t. Go ahead and pop that exponent out front. So ln of 3 is equal to 0.06t times ln of e. Again, ln of e is just going to give us 1. So if we divide both sides by 0.06, we end up with time being 18.31 years. All right. And then if we take a look at the last one, this one was founded by using current interest rates. All right, so this one, based on the most current interest rates, we want to figure out how long it will take for an investment to double. So our goal is to double if it earns 0.95% interest compounded continuously. All right, so we know we're going to start with A is equal to P times E to the RT because our compounding continuously. So we don't know what P and A are, but let's go ahead and use $2 and $1 times E to the rate. Now be careful on this one, since it's 0.95, when you move it back to, your rate's really going to be 0.0095, so really small, times T. That 1's out front, so divide both sides by 1, and really it's not an issue. Now we can use ln's on both sides. ln e to the 0.0095t. You can bump that out front on both sides. Well, just on the right. So ln of 2 is equal to 0.0095 t times ln of e. ln of e is simply 1. So your last step, when you go ahead and divide by 0.0095 on both sides, you end up with t equaling 72.76, or not 76, 96. So that's the whole thing. Years. And that just kind of goes to show you how terrible savings account interest rates are. So some people might choose to do a little bit more high-risk savings accounts, or do mutual funds or certificates of deposits. There's lots of different options out there. But generally, savings accounts are really safe, which is why a lot of people choose to use them. But that's it for financial applications, and hopefully this helps.